Okay, so thanks everyone for joining. We have a couple items on the agenda today, um, starting with tracker and chain rules integration. Um, so Marius or Jonas, I don't know which one of you want to lead that discussion. But if you don't mind, just giving everyone a general update of what you're working on, and then bring up any of the questions or issues you might have about the work.
Okay, so I'm going to share my screen.
Okay, let me just make sure the permissions are there. Yeah, give it a shot.
It shall work now.
Yep, we see it.
Yeah. So basically I wanted to learn how automated differentiation works for machine learning, and I looked over several implementation of this tape-based algorithm, and one of them is this tracker. And I had issued with some second-order derivatives, and so what was wrong there was some rules, some rules from diff rules, the diff rule package. So some rules there wasn't correct. Actually, some rule written by Mike Innes inside tracker was not correct. And I have thought, okay, if this doesn't work, I think it's better to switch to chain rules. And here we are. So I assume maybe I think maybe everyone is familiar with the tracker, right? Am I right? Or let me move this on. So if not, so maybe a very quick introduction. So we have some floating point numbers and we want to track them. So we create another structure called tracked real, and we record the original floating point number, the data, and some tracking information. And the tracking information we are going to record is, the pullback and the parents of the current node in the graph. Now I did the change. So we now have tracker working with chain rules, but only for the first order derivative. And let me show you maybe just a quick example, just for fun, just to maybe remember how tracker works. And so here I have a number, and I want to track it like I don't know, 5.0. And what we get here is a tracked object, and we can dump A, and we can see the fields. So we have the data and the tracker information. Now the tracker contains nothing because this node has no parents and there is no pullback at all. And now we can do some, maybe B is 2 times A, and then we run this and we can dump B this time, and we see that we have we have inside B, we have B is a tracked real, and we have 10 inside it. Of course, it is the data, and we have track information, the pullback, and we have the parent. The parent is 2 here, an integer, and A basically. So we create a graph with nodes. That's the main point. And now if we want to get the derivative of A with respect to B, we simply go and call back on B, and then we extract the gradient of A, basically A tracker dot grad, and this shall be 2. Yes. Okay. Now it works with first order derivatives. Now we want to do some second orders. And here I had issues. So I was sort of, it's difficult to have them with the current chain rules. And now I want to show you why. So I created a function, called f. And this function is this expression. We don't care too much about it for now. But let's say I want to create a custom rule for this function. And inside the custom rule, I do the primal, of course, and here's the pullback. Now the pullback is not really the derivative of this, but anyway, it's a custom rule. I do whatever I want. So I want the pullback to be like this. So this would be the gradient. Why not? So this is the custom reverse rule for my function. Now I want to say I want to track this function. So whenever I call my function on a track real, I do a call the track method from tracker. And now you should see the console here. Okay. Now let's create a tracked real number, which is this time 2. And now we call the function over this track real number. And we get this new node. So we had a node called T, a track real, and now we have another track real. So basically we have a graph. We can dump this FT and we can see, the graph. And it's we have the data, the result of calling our function. And you see here we only have 2 nodes in the graph, so it's more like where is that? One moment. Okay, some problems. I think I've lost some GeoGebra stuff. Okay, so the bad thing here is that I've lost my drawing, but anyway, I will try to explain without it. And now what I want to do now is to get the gradient of my function here, of my custom function. And just like before, I do call this back method. And when I do it, and then I access the gradient of T. And this is 33. But now it's very important to see. So what we got here? We got a scalar number. So if we want to take the derivative of this, we will get 0, which is not correct, right? So what happened? So I think I will have to redraw everything again. So basically, we had a node here, and this is our graph, right? So A is actually T, and B is actually FT. Okay. Okay. So this is our graph, and the only thing we did now was to take we parse the graph from the top to bottom, and we applied you know, the pullback, and at the end we got a number, yeah. But if we want to get the second order derivative, something else must happen, and what shall happen is that we have to record all the operation performed on the backward path. Like here we have 1 plus x plus we have to track everything here actually, and this, what does it mean? So we will have here another node which is let's say 1, what is, and here is legend, and the legend is 1, right? And we have another node here, and we have links from this to this, from this to this, and B would be, you know, B would be 1 plus T, 1 plus T, and then we will have what expression have we had there? So basically the next is 3 times 3 times 3 multiplied with like x times 2. So we have here another node for this is x. So 3 multiplied with x times 2. And now we have another node for x times 3. And now, of course, we have to add these nodes together, basically. So we have another node here and a final node here. And we have to sum this with this and sum this with this. And then we have another sum here. So it's the idea is that the graph we create initially, which is just the one here, is not fixed here. And when we do the back propagation, we want to record everything, so the graph will get bigger. So the first order derivative that we will have would be here in the node F. And this time, instead of getting 23, we will get a tracked real of 23. And when we take this node and we do the back propagation again, we will end up with the second order derivative. So that's the whole thing. Now, so this is the idea, but now how do we implement this, right? So what we have to do to achieve that. So let me show you the original track method. How do we apply it? So we have the function f and the argument, which is just this just our t here. We just have one argument, and we call the chain rules for we call the chain rules that we define here, and we apply the chain rules over the data of the track serial, of the track number. So we don't we apply it over the data, meaning we have an untracked primal and also an untracked pullback. So here we just discard all the tracking information. So when we do this, yeah. And then we make another track object, which would be ft here. We keep the data here, which would be y. This pullback, which would be an untracked pullback, and of course the original the parents, which would be excess. Yeah. Okay, but this is not what we need. So when we do this call here, and we discuss, as I said, we get rid of all tracking information there. Yeah, so we won't be able to do any order, any second order or any higher order derivative if we do so. So it means that we have to do something different. Yeah, so here we have a candidate, another tracking approach. Yeah, and this time we do a primal, which would be an untracked primal, just like before. Okay, so we just apply this expression over the data of t. That's what we do. But this time, as you see here in this rule, so we call the reverse rule over the tracked data itself. So we have the reverse rule of f, and here we will have our t basically, and not the data of t. And the point is that here we only need the pullback, and we don't need, we no longer need the primal here. We will get a tracked primal, which we don't need basically. So we will even get infinite recursivity here just because of this. And let's try it. Yeah. So I will restart the console. So let's rerun this. Okay. And now we have another. So we have another tracking method, which I define here. And if you see, so basically, I just get this infinite recursive because
Did the audio cut out for anyone else?
Sorry?
Were you just speaking?
Yeah, it cut out a little bit for me too.
Can you hear me now?
Could you just repeat what you just said? We just lost the last sentence.
The last sentence. So basically, I have said that here we get this recursivity, and it's because basically what happens here is this. See, here we will have f call again, because that's the primal, right? The primal will call f over the arguments, And what this primal will do, we'll call the candidate track again, and again. Yeah, and this is just wrong. And one way to solve this is to come here in the chain rules and tunk the primal. So basically, chain rule was designed like this. Let's do some. If you need the gradients, very likely you also need the primal. So let's compute this together. Yes, but not always. Sometimes you only need the primal. You only need the gradient and not the primal. And we have such a use case. Yeah, so that's what I'm showing you here. And if I do this, this will work this time. Again, and we have this. So you see, I had to tunk. I'm not sure how to spell it. Tunk or tunk. So we have to wrap the primal into a pullback, just like the gradient, basically. This approach is okay for my example, but it's not very safe because a user might come here and say, okay, maybe in order to compute this, I also want to do like cosinus of x. Why not? And then I tunk this expression. So and stuff like this. So this is not safe, and we risk to get this infinite recursivity. And then how can we solve this? So basically this shall stay like this. We have to wrap the primal calling here because we don't need it for tracking, for the tracker. We don't need it. We do our primal here, which is an untracked primal, and we need the pullback to be tracked, right? And we have a third track, which is the super track, which is similar to what we saw. Yeah, so we still do an untracked primal, and the difference here is that we call the chain rule we define in a pullback. Yeah, so we wrap everything in a pullback because we shall not risk to get some infinite recursivity here because the user define a custom rule. I don't know how. Yeah, but the idea is the same. You want an untracked primal and a tracked pullback. Yes, and that for each rule in the chain rule, we have to tunk every primal, which is expensive. I mean, if the primal is cheap to compute, we don't care. But if it's expensive, we have to wrap the primal. Just like we do it for, there are chain rules for arrays. Or you have several arguments, and if we look over the chain rules documentation, you are told, look, the caller of this method might not need all the gradients that you provide. Maybe he needs only the gradient for the first two arguments and not for the rest. So you will have to wrap everything. So ideally all gradient with this, or at least the gradient which are expensive to compute. So I think we shall do something similar for the primal. So people shall be aware that there are use cases where you don't need the primal and you have to do something like this. And that would be my proposal. Yeah, so I'm thinking to request this change from chain rules such that I can implement higher order derivatives in tracker. So that's all from my side. Any questions?
Yeah, anyone who has questions, I guess, can feel free to unmute. But yeah, I guess off the top of my head, I don't know how much I trust chain rules writers to use thunk when they should be using thunk. Yeah, so that's my only concern, I guess, with this approach is that it kind of relies on everyone being a good, proper rule writer, assuming that chain rules does accept this kind of change as well.
Yes, so I have thought of this a lot. So kind of it just like for like I said, for every gradient, I mean you have a function with several arguments, and you have to thunk the gradient of each argument, and this relies on the developer. I mean, how can you impose this in chain rules from the design? You cannot. Yeah. So
one barrier, I think, which is maybe less technical, but chain rules does not expect people to thunk the prime. The thunk is purely reserved for the actual tangents, cotangents, I believe.
Yeah, I think
you
that
mean
was the proposal, right? Is to make a request to change that policy.
yeah. I mean, if you look in the package, and I think maybe here this is chain rules, and we have the source, and we have, we deal with arrays, right? So maybe for track real, I think it's but I think it's more critical for arrays. I mean, nobody wants to do a convolution twice, right? So it means maybe
Just
in
thinking a little
base.
out loud here. The problem right now is that strip it, if I understand correctly, is that you have to strip the tracking off of tracked arrays in order to feed them to the R rule. Is that correct?
Sorry.
The problem is right now you have to strip the tracked part off of the tracked arrays to feed them to the R rule. That's what the track method on the right does. So they're no longer tracked arrays, which means the nested diff no longer works.
Well, I think
No longer.
more precisely is the first order track value aliases with the second order track value in terms of the R rule getting called, right? So you have to strip the information. Like stripping the information is the way you avoid that aliasing. But like in terms of what's causing the problem, I would say that aliasing is causing the problem. And yeah, I guess thinking out loud, maybe an alternative solution is to keep some information about the order of the tracked value.
Or
If you-
even, would it not be sufficient to define an overload of track for a track itself, which instead of first removing the tracking and then feeding the tracked array to the R rule, just feeds the tracked array directly to the R rule? Because then I would think you would maintain the graph as it goes all the way through the R rule. And as long as the R rule is written generally enough to not break on tracked arrays, then you get that whole graph back and you don't lose it. But I feel like I'm missing something because we've probably talked about this at some point before.
Maybe not, but what you propose is basically this. So here we have this, and this will call the candidate track again, right? So that is right. So I'm calling this function here, ft, and when I go into our rule, this ft is going to be called again because access is t in our case, right? And then we
No,
have a.
that's not what I'm proposing. What I'm proposing is because track is the kind of internal primitive we use for tracker to run AD on a function. And right now that would look up in our rule. But what if you track the track function itself? What happens then? Because if you track the track function itself, that means you're doing a second or higher level derivative. That's the only time that would happen.
If I track the track method itself,
yes,
then let's say if we go here, so maybe I can take this function and then I can yeah, so f would be here, we will have f would be track, let's say pseudocode here, no, track, and the arguments would be, I think, a function, right?
Yeah.
Because we track the track of a function of some argument. Let's say this would be big F, and okay, and then we have our original function and this, and then we have to, you propose to call a reverse rule for track that we are going to define, right? F would be another argument, and then here we will have I think I don't know, data, or so we see what we go here, and now the question is what the reverse rule shall do here over track.
So I'm not sure what the internals would look like. I think the biggest point would be that we don't call data at all. Because the point with this overload would be to
we don't host data.
No, we don't call data when where we're doing a
we
higher
don't call
order
data, yeah.
derivative.
Okay.
And then we run, eventually what happens is we call our rule on f, the original function, with the x's, without calling data on the arguments first. I don't know what that looks like exactly, but that would keep the graph, right? Like that would make sure that no derivatives are being lost. You would track through the R rule, which is fine. And then basically you're differentiating. That means you're differentiating through the R rule. Whereas before with track, you are explicitly not differentiating through the R rule. You're letting the R rule be a primitive. If that makes any sense.
Yeah. So here we have the R rule of track, and this. So far, the primal would be. We will have to call the. So I'm not sure if we have much time to. I would have to think of it, and maybe.
Yeah.
We have other.
This might take some time. I haven't. This is something I only just thought of, so it may take. Yeah. No worries.
Yeah. Okay. Thanks for your time, and yeah, maybe we have a better solution. Yeah. So let's see. Thank you.
Okay, great. Yeah, thanks for sharing. Keep us posted, I guess, on Slack if as you like work through the details of how this might actually work out, and then maybe we can discuss it next time. if we have another prototype. But I think before, with the last 20 minutes, maybe we want to switch gears and let Abhirath, I think you had some questions about attention layers in Metalhead, and then also just general flux documentation stuff.
Right. Yeah. Hi. Maybe I'll go over the docs first because that requires me to share my screen. So I hope that's okay. I'm just gonna try and do that. Just 1 second. Right. So is my screen visible?
Yeah.
Cool. So this is sort of like what I started with. I just put together like documented package where I had like the 4 things that I could think of off the hat, just flux, metalhead, zygote, and nlib. And we have this sort of an arrangement, and there's search. It doesn't really work locally, but I'm guessing that's going to be like that is something that gets sorted once I upload this somewhere, because right now all of this is very like local. And it seems to work fine. Like I can switch between packages pretty easily. Zygote is still using white mode documenter for some reason. And yeah, I can and it seems to be working fine. So I know that this is like the basic outline, but I wanted to get some feedback on what exactly is going to go, say, in this top bar right over here. So obviously, right now we have Flux, Metalhead, Zygote, and 11. I can think of a lot more things, but to what extent do we expand the ecosystem on the top bar? So that's point number 1. And there's also something else that I was thinking of, which is that if we do use this sort of setup, a lot of things that are right now in the Flux docs can sort of go away, because say nlib docs are also going to be talking about all of these functions, these neural network primitives. And I get why we want to keep some of these. So maybe like the ReLU and the activation functions and those sort of things, but the other things, they've sort of they'll sort of go away into nlib. And so that's sort of what I wanted feedback on.
Yeah, so I mean, I guess, yeah, exactly. I think Brian and I think are thinking of the same thing in terms of the header, which is to refer to SciML here. So they have a bunch of categories at the top, like drop-down menus, and then various packages underneath
Right.
those.
So, right. Okay. I
So
think that's visible on my screen.
yeah, we can see you looking at SciML right now. Yeah.
Right. Yeah. So basically like this. So so again, the subheadings, like what do we put under these various headings, and what packages can come. So if the reason is that I know some packages, but I'm pretty sure I'll miss something. So I just wanted feedback on this, so that when I'm putting them together, I can just make a list of all of them and then put the links through.
Well, so we can do this, I guess, collaboratively right now. At least for me, off the top of my head, I would have like a models heading, which would link to places like Transformers and Metalhead. I would have a training heading, which would so like if you click on, let's say, solvers or modeling, let's say right now.
Right.
So see how there's like equation solvers, third party, blah, blah, blah. So like similarly, we would have, let's say, training, and then we would have like utility packages that would have like parameter schedulers, things like that. Then we would have
Flux, like fast AI,
like
I guess.
fastai.jl, flux training, data augmentation, those kinds of things would all be under training, but separated into this like subcategory of low, mid, and high level training utilities. And then There we could also, yeah, I mean, okay, so the other thing I could think of is having like an ecosystem drop down that has things
Right.
like MLJ and whatnot, like MLJ Flux,
Mhm.
things that aren't required for like your vanilla Flux setup, but maybe would be the kind of thing that people are looking for. And then the last thing is data wrangling. So this would be
Mhm.
ML data sets, ML utils, things like that.
So where
And
does
I think,
Zygote and nlib go here?
I guess AD. I mean, it would be good to have,
Yeah.
Especially since we're kind of in the works. We've been doing all the preparatory work to make Flux AD agnostic, and in principle, it should be at this stage. But not,
Mhm.
you know, we haven't gone and verified that every AD is correct. So, but as we kind of approach that future, it would be good to have all the different AD packages listed there.
So I know
And then
Zygote and
lib to
Tracker
me is
are
like API reference.
okay. So like, does that come under like a separate subheading or
I mean, I assume it's possible to have drop downs and top level links in that banner, right? So not everything has to be a drop down.
yeah. True. So I could just put like nlib over. That's completely
Yeah.
fine.
I think one
I could just
start could
label it
also
as
be to have, if there's not a clear category, to have kind of a building blocks section or some sort of catch-all which lists a lot of the components of
Mhm.
Flux that you wouldn't usually use as an end user, but you might use kind of as a power user, as someone working on libraries yourself, and then Zygote and nlib go to that category, where something like parameter schedulers would go into a different category, as Kyle mentioned. I don't know if, is it possible to add links to pages in particular doc sites in the top bar? Because then we could be a little more flexible about this. But if it's only possible to add links to packages, then that seems the path of least resistance is just to.
No, sorry, I didn't catch that last point. Like add links to
So for example,
add
if we
links
want
to
to add a link to in the top bar to the SciML showcase page that you see on the sidebar, would that be possible? In
I
like
think
say
it
the
should be,
drop.
but let me just check that. So
If
maybe I
it's
can
not,
get
then
back
that's
on that.
fine, right? Like we package level granularity is already an improvement. We just need to see what is and
Sure.
what
So
isn't possible.
yeah, that makes sense. So right now, obviously, like I said, this is like obviously a very rudimentary thing. I'll work on classifying all of these into these neat little bins, maybe, and then that's sort of like the start. But I also wanted to discuss, like I said, the fact that right now we have gradients in like this different page. We have nlib over here, and I've always felt this makes a little bit of a clunky documentation structure for Flux itself. So can we just put all of this, like if we are putting all of this in the top bar, do we really have to keep this around in this Flux docs? Or if we have to keep this around, I mean, they do make sense, but is there a way that we can sort of integrate it a little bit neater instead of just, keeping the API reference there?
I think the sidebar existed mostly because we didn't have the top bar. So in that
Right.
sense, if it's redundant, then I don't see any reason to keep it. It might help to have some sort of more central page that has links to each of these sections somewhere in the either. I don't know if we can make a landing page on top of all the doc sites, or if it's something we'd have to put, say, in the Flex docs. But something that links to all of these sections would help. But otherwise, yeah, I think this is mostly redundant with the top bar, if we can get the top bar working.
Right, that does make sense. So the other thing that I wanted to discuss obviously is because like if you see Lux, they've gone towards a completely different sort of documentation which looks somewhat like this. And this with the landing page and with this, with having this ecosystem thing over here and with the tutorials, it looks quite different. So is this something that we can do for Flux, or does multi-doc just make a lot more sense right now in terms of what we need?
I mean, I think it's better to stick with something that is where the work of the documentation systems being done by other people in the Julia community. If we go with something like very off the well-trodden path, and we've tried that with a couple packages before, and I think it hasn't worked out. I think it would be even harder to do something that, like, I'm pretty sure Lux's docs is using like a kind of framework agnostic documentation system, right? Like it's not anything Julia specific.
Yeah, I think this is Vue and WordPress, but I'm not really sure. Like that's what I think I saw, but I could be wrong. Yeah, that makes sense. I mean, okay, so I think multi-doc is like a good starting point for now. Maybe we can stick there. Okay, so maybe the next community call, I can just rewrite some of this and have some feedback on that. And once we shift this to like a package, and then maybe we can start to slowly also change the documentation in Flux to reflect this. And once that's ready, we can sort of maybe deploy it, I guess, if that makes sense.
Yeah, sounds good.
Cool. So that that was it for the docs. But I wanted to talk about Metalhead because uh there are a couple of things that I wanted to work on, but I don't have like a lot of time, but I do want to give some time to it. So there's one thing that's been bugging me for some time, which is that the attention layers in Metalhead and the model, which is just currently that's just the vision transformer model that we don't really have variants. They use the NNlib version of the attention function, which is I'm presuming very performant, but also like that's not usually what we've been seeing in computer vision libraries, where they don't really use the torch or the torch vision version of like attention. They tend to write it out by hand. And the reason for this is because when we look at other models like say DEIT or CAIT, K8 or all of these things, they really have very different attention layers, and so it just makes it a lot easier if you're writing all of the attention layers for like specific models instead of like using a catch-all, because then you end up having to do a ton of reshapes and resizes, and you have to fit the attention to work with different like array dimensions, which is not always the case. So like I guess my point here is, so first of all, should we be using like a written out layer instead of say something from NNlib? So if we do that, then the question is, what do we use to write that? And obviously native reshapes are fine, but I was thinking of, and I know I've brought this up before, maybe Tulio or TensorCast, if they're ready, or if they're at the stage where we can use that to support Metalhead. And if that can happen, then what I think I can do is maybe if I can write the implementations up and maybe open a lot of issues for other model implementations, and then people can go from there. Because I noticed that since my GSOC, there's not been a lot of model implementations being added. And we do need like vision transformer model implementations, but I don't really have the range to take up all of them right now. And so I feel that if we write out a couple of layers and just show how it's done, then if I open up some issues, maybe people who are going through it can just, latch onto a couple of them and just give it a whirl.
Yeah, I mean, I guess in the general idea of having a good example working and then opening issues to get contributions, I'm on board with that. As far as the attention mechanism goes, yeah, I mean, I don't have a lot of experience with the full sweep of vision transformers that are out there. But like in my experience with working with attention, you have, I guess, two things that need to be kind of customized. One is the attention function itself, which is then operating at the level of tokens. And then the other thing is kind of the query key, mapping that can change, especially when you have data of like different shapes, like 2D and things like that. But like at least in cases where I've had to write code, this is not in Flux, but cases that I've had to write code, where I need to swap these kind of pieces out, it felt like attention is pretty modular. But I don't know if it's different for vision transformers where it just the combinations just get so crazy that it's essentially like writing a different layer every time.
To some extent it does remain modular, like if it's with like the simple ones, but you're right that there are some, like especially with like Swin and things like this, where it gets a little weird, and at that point it's actually like just easier to write a new layer instead of trying to, come up with some like one function which can write everything. So in that sense, I think it makes sense for us to be able to have that level of, like code written out in Metalhead at least once or twice so that people know how to deal with it. Of course, the major issue with attention is, of course, that there's a lot of reshapings, especially because you mentioned that we're dealing with tokens. There's a lot of reshaping going on to sort of deal with the projections and things like that to feed into the attention layer itself. And so that part is really easily handled if you use like some sort of package like TensorCast or Tulio, where the casting and the reshaping is a lot more intuitive to write out in like INSM notation, as opposed to say if you have to write out all the reshapes, it gets really long and annoying, and that sort of puts people off who are looking through this code for the first time.
So you tried this during your GSOC, right? And do you remember
Mhm.
why we didn't do it? Was it just we didn't want to add the depth?
Uh, Among other decisions, I think so. I also think that it was because at the time we had some other considerations that maybe we just didn't look at.
I remember
And
something about performance with TensorCast. I don't remember what it was. I think we couldn't match the performance of something
Mhm.
else, and I don't remember what that was. So that would be worth revisiting. So runtime performance is one thing. Compile time performance is a whole different can of worms, which we might want to touch on, but only if we can figure out the runtime performance piece. And then
Right. So
TensorCast also, I don't know how well it works with arbitrary dimensions. So if assuming we want to be able to handle 2 and 3D inputs, for example, I don't know how well it extends to that. I think Tulio is a little it's not great there, but TensorCast might be better.
Right, sorry. I just remember that in the NLib PR where Carlo added this the attention functions. I remember that in the comments for the code he has like the Tulio functions, the equivalence written in. So I don't know if that's just like for like just to show users that this is what it is, or if that actually, if that code just directly works out of the box. I suspect that it's the former more than the latter. So I don't know how much modification it'll take, but I'm open to spending a little bit of time on this and maybe comparing Tulio and TensorCast. I don't know which one is better. I strongly suspect it's TensorCast because it seems like a better library to like work with array, like resizing and reshapings and those sort of things, but I may be wrong. So maybe I'll come up with some benchmarks and then we can go from there. Maybe that's something I might take some time on, but I'll start working on that.
And it might be easier to
Mhm.
write out the models that need these specialized attention layers first, and then pull out the abstractions later into NLib or wherever have you. Just because it's not clear what those abstractions look like right now. I think one thing we've discussed before is that there are libraries like Neural Attention Lib, which have tons of abstractions and optimized, well, mostly optimized kernels for different attention types and whatnot. But the level of complexity there is a little mind-boggling. So if having some of these custom attention layers and having kind of a rotation of them for which have a limited amount of extensibility, but have enough to work for some family or group of families of models is enough, and they don't take up that much code, then I don't see any issue with doing things that way instead. At some point, it's not worth sinking in a lot of times for trying to find the perfect abstraction only to have it stop working the moment someone publishes a new paper, right?
Right. So actually, I'm sort of going the other way on this because I feel that so I remember during the GSOC we spent a lot of time working on abstractions for convolutional networks, neural networks and models, because over there it's actually really like it's easy, and I think it's sort of
Yes.
meaningful to think about this. But in attention models, I've sort of found the other way, which is that people just seem to write an attention layer every time from scratch, simply because there's a lot of modifications going on.
Mhm.
And so it's more useful for us to like just provide a couple of examples and have people go from there, rather than providing a catch-all attention layer that claims to do everything, because that's just not going to happen, because there'll always be a crazy new paper like you mentioned, which is going to do something that our function won't. So I feel like if I can write out like two models, maybe like all VITs are already there, so it's just a matter of rewriting them, and maybe one other model, I don't know which one, uh and then just open a ton of issues, or maybe just one big tracking issue and leave all the models with the papers linked. I'm hoping that somebody who's stumbling up across the repo and has a little bit more time than I do will investigate, and then the code is a lot easier to read. And so if we do use like Einstein notation and things like this, it's a lot closer to what other languages and other packages use. And so it's a lot easier for users to map it to their mental model than, instead of doing something completely different.
Yes, absolutely.
Yeah. I mean, there are packages other than Twilio and TensorCast, right, that are somewhat more limited in scope. That still have basically einops, but for Julia. So it might be worth.
Like, can you mention anyone that comes to your mind that's like maybe fitting what we do? Because I know einsum.jl works, but from what I know, Twilio is just like einsum.jl, but more.
One tricky part with
Right.
Twilio is that the GPU performance may be less than optimal for some of these more tricky manipulations you'll see with the attention layers. Whereas TensorCast will, for better or worse, it'll degrade down to a set of already vectorized operations, which you probably would have written out by hand for the most part. And that's a library like that, or one of the other libraries in the list, Cowlink, which also worked a lot like that, might be preferable. But again, it's more like fine. I think it'll become clear what makes the most sense once these models start being written. Because in the absence of a nice end-to-end benchmark, it may be difficult to determine what makes the most sense.
Right. So maybe let me start working on TensorCast and Twilio, because those seem like the most obvious ones. I feel like TensorCast even more so than Twilio. And maybe if I have some benchmarks, I don't know when that'll be, maybe 2 meetings from now, but we can sort of discuss that and go from there. I am also looking at this package linked here called tensor operations. But I don't know how this will be performance wise. And also AD and GPU is a big concern for us because obviously this all these models are going to be trained like on the GPU. So that's sort of my worry more than anything else. But I'll take a look at this and maybe come back in a couple of meetings.
Yeah, I mean, I would maybe look at tensor operations and tensor cast as like your first
Mhm.
two.
Sure. Yeah, let me look at tensor operations a little bit more. I don't know how much the AD and GPU thing is there, but it does seem to have support. So it should be a matter of just trying. I just wanted to bring up one more thing, which was, could I just get access to like the Cyclops server again? I seem to have lost that. I do want to try and run some of these on the GPU to just check if that works or not. Because I don't have like a GPU installation on with Julia available to me.
Yeah, we can ask again, and see what if Julia Computing can help out.
Cool, yeah. So if that's possible, because that makes a lot of the testing for GPU easier, because right now there is a lot of code in Metalhead which has just been written, and we sort of hope that it will run on GPU, but I'm not sure that it does, and so I don't want that to happen.
Well, there isn't there.
Until
I
I
mean,
can.
we have GPU testing on CI, so it
Uh,
should run.
yeah, but I don't know how thorough the tests are, and also it times out a lot, and so I'm always worried about uh tests not covering edge cases or things like that, because I see that, okay, 1.6 seems to time out, and
Yeah, the rest.
the other one
Yeah,
seems to work.
yeah. Other than 1.6, most of them like generally pass. I know because that's made it a lot easier to have people contribute to Metalhead, is the fact that I had the GPU test available. But yeah, I mean, coverage could certainly be an issue. But yeah, I mean, for prototyping, I think it, especially for something like attention, it makes sense to have an interactive GPU available to you. So yeah, I'll ask and see what we can do.
Sure, that sounds good. Yeah, thank you so much.
All right. Well, I think that's everything. So unless there's any last minute items, we're a bit over. So when we end here today. All right.
Yeah, if it's possible, I have one little question.
Okay.
I think I will just quickly share my screen. Um, I will not going in the details. It's something which has to do with Tracker, and it's basically.
Can you please zoom in the code such that you can see?
Sorry, I didn't get it.
Zoom in.
Yes.
Okay, thank you.
It's this part, and when generating methods with metaprogramming stuff like this, and then overwriting the function in the same line, I sometimes get some weird warnings. I hope they will come up now. It always says some incremental compilation may be fatally broken because the same method is overwritten at the same line. Yeah, come up now.
Can you go back to the code with the eval statement? Okay.
I think it always when it pre-compilates stuff. So Maybe I just changed
Are
something in the
the
code.
types there different always? Like type vector 1, type vector 2, are they all different?
Yeah, they essentially like here we have all combinations of tracked and untracked arrays, and for batch norm we have 5 array inputs here, and that results in 31 methods, I think, when we cover all possible permutations or combinations, and we can generate them in a few lines just by generating some the types above here, but there are some, I think there are some duplications in the permutations, and maybe this results in the warning. Maybe I can reduce the warning now. Yes,
Yeah, I mean, that
that's
would
what
be
I mean.
my. Okay, so can you?
Post two of them in the chat, maybe. Yes. So I think I have to test if the error also occurs when the just a function, one more method is added to the function instead of redefining the same method. Maybe that's a problem, that duplications of methods and not duplication of functions. But having something like that in the release, I think that's not optimal.
So I think the main thing to make sure you have a lot of parameterized array types here is that even when the text of the type is different, but the dispatch is the same, so it's the same method, you can get this kind of error. So in terms of your type permutations, making sure that they are all actually specific, unique dispatches that don't overlap with each other.
Shouldn't be the case, I think. I mean, if you have a function, batch norm with different types for whatever function, and calling the same function with the same, so I think it shall be fine. So it looks to me like the type vector 1 and the type vector 2, or any of the type, they are the same. And when you mix them, when you combine them, some permutation would be, basically the same.
Yeah, I also think something like that, because when generating the permutations, this function is designed to generate permutations where every item in the array is different. But in this case, maybe 3 or 5 are tracked, and the other last are not tracked, and then duplications occur.
Yeah, that's clear
okay.
what happens.
So I think I have to filter out these, and then it should be fine.
You need kind of groups of permutations. I mean, you have a group of 3 parameters which we have the same time, the first 3, and then you have, I don't know, so something like that.
Yeah. Okay. Yeah. Hope then this will go.
Maybe you don't need permutation, you need combinations, which can, I mean, it's something like you have many combination of 1, 2, and 3, but only one combination of 1, 1, and 1.
Yeah. I use combinatorics.jl in the for that. Maybe it has some method like this, but yeah, make more sense, I guess.
Okay. Well, I think everyone has dropped off, but thanks for joining. And yeah, I think your issue is that your types are not unique, or at least they're not unique with respect to dispatch, even though they might appear unique. And so yeah, so I would debug that, and then you can post on Slack if you run into issues, and we can try and figure it out from there.
Yeah, thanks.
One more, maybe a quick stuff. So Jonas, you know, I introduced this constant node. I'm not sure if you took care of it. So I'm not sure now if that is actually a good idea. So I would say we shall at least debate if we introduce that or not. So, but let's continue on Slack, or maybe we can meet the next week.
Yeah.
So let's see.
Okay. Well, I'll end at least this call, and you guys can talk about the tracker stuff. Yeah, maybe separately. But yeah, thanks for joining. We'll
Yeah, thank you.
see you in
That's
2
fun.
weeks.
Bye.
Bye.
Yeah. Bye. Enjoy your weekend. Bye bye.